video, I'll discuss how to find the area under a curve. In geometry, we have lots of shapes. We've got rectangles, triangles, trapezoids, circles, etc. And if we want to find the area of a shape of those, then we've got defined formulas. We can just use these formulas to calculate the area of these shapes. However, if we have a shape that has a curve in it, then finding the area of this shape gets trickier. So for example, if I've got this curve and I need to find the area which is enclosed between the 0 and this number, which is this area, it is not straightforward. So what can I do? Well, I can use the shapes that I already know how to find the area to and stuff them in this curved shape and then work it out. So for example, I can use rectangles. I know that the area of a rectangle is the length multiplied by the width. So if I take multiple rectangles and stuff them up here inside the curved shape, then I can find the area of each of these rectangles and then add up the areas of all of these rectangles to get a total area which is close to the area, the true area of the curved shape. If I want to get closer to the true area of the shape, then I can make these rectangles narrower. That is, I make as many rectangles inside the curved shape as possible. So by narrowing the width of the rectangles, I can get a more precise or a closer answer to the true answer of the area of the curved shape. And of course, if I want to get even closer, then I get the delta x even narrower. And as delta x, which in this case I'm going to call dx, approaches the value 0, gets so close to the 0, the area of the sum of all of these rectangles is going to be as close as possible to the true area of the curved shape. If I use integrals to find the areas under a curve, you will see that the areas which are above the x-axis, they are going to be positive. You're going to get a positive value for them. However, the areas which are under the x-axis, they are going to be negative, meaning that they are under the x-axis. Now, to find the total area of the region under the curve, you should not add these areas algebraically, because the minus here just indicates that the area is under the x-axis. And if you just use it with a negative sign and add all of these up, the negative is going to be eating away from the positive here, and it's not going to give you the entire or the total area. It is going to give you the total area minus part of it. So what you can do is find the areas of each separate region, and then whenever you've got a region which is under the x-axis, find the absolute value of it before you add it to the rest of the areas. So be careful. You've got to use the absolute value of the area. The absolute value of the area means if it is negative, you just flip the sign to make it positive when you add up all the areas. Let's take an example. We need to find the area under the curve between the curve y equals to x cubed, which is this curve, and x equals to -2 and x equals to 1. So how can we find the area under the curve? Instead of stacking up all of these rectangles and making them as narrow as possible and making sure that the delta x is approaching the 0 and then doing the addition, we can use integrals, because integrals is a summation. Alright, so what we're going to be doing is divide the areas. We've got here two areas. One of them is below the x-axis and the other one is above the x-axis. I'm going to call this area A and the other one B. And then I am going to find the integral of the function. So this is the first step. Find the integral of the function x cubed. If I integrate it, it is going to be equal to x to the power of 4, and then you're going to be dividing by 4. So this is like quarter x to the power of 4. So this is the integral. This is the basic integral. Now I'm going to evaluate this integral in the region from -2 to 0, and then I'm going to also evaluate it again from 0 all the way to 1. So I've got 2 steps. First, I'm going to find this area, and then I'm going to find this area. So let's just start with area 1, which is indicated by the letter capital A. This is going to be equal to, this is the answer of the integral. So you've got quarter x to the power of 4, and we say we're going to integrate it, evaluate it from the lower limit -2 all the way to the upper limit 0. And if you remember, how do we evaluate these integrals if we've got limits? We've got to substitute with the upper limit, and then minus we substitute with the lower limits. Alright, so you've got the 1/4, which is just a constant. I substitute first with the 0, so instead of the x, I'm going to put a 0. Minus, then I'm going to substitute with the lower limit. So instead of the x, I am going to put -2. Do the math, you get 0 minus, and this is going to be equal to 16, positive 16. So this is, the entire thing is going to be equal to -16 right here. -16 multiplied by quarter. I can do some simplification, so I divide by 4, I get -4. So the area A is equal to -4, and you can see that it is negative because it is under the x-axis. Now I'm going to do exactly the same thing for B, changing the limits. So the area B is equal to, I take the result of the integral, which is quarter x to the power of 4, and I'm going to evaluate it from 0 all the way to 1. So how do we evaluate it? We have to substitute with the upper limit 1. So instead of the x, I'm going to put 1 minus, then I am going to substitute with the lower limit, which is 0. So instead of the x, I'm going to put a 0. So you've got here quarter multiplied 1 to the power of 4, which is 1, minus 0, which is equal to 1. Quarter multiplied by 1, this is quarter. So B is an area which is above the x-axis, and it makes sense that it came out as positive. Now to find the total area, don't forget, anything that is negative, you've got to find the absolute value of it to make it positive. So we add actually the actual area of A plus the actual area of B, regardless of whether it is below or above. So the total area is going to be, usually add the absolute value to everything so that we don't forget, but like it's basically you just add it, the absolute value to the thing which is negative. So this is going to be A. I know it turned out to be -4, so the absolute value of -4. I'm going to add it to area B, which is already positive. Alright, so -4, the absolute value of it is +4. Then you've got the quarter, which is already positive. 4 plus quarter, this is equal to 4 1/4, which is 4.25. So the total area of A and B under the curve x cubed is equal to 4 1/4. Another example, we've got the curve y equals to x multiplied by x minus 3, which is this curve, and we want to find the area under the curve from 0 all the way to 5. And you can see that these two areas are that constitute the entire area. One part of it is under the x-axis, and another part is going to be above the x-axis. Now, an easy way to integrate this is firstly to simplify it. I can multiply the x inside the bracket. So this is the first thing I'm going to do. X multiplied by x, that is x squared. And then you've got x multiplied by -3, that's -3x. And I'm going to integrate that. The integral of the first one is x to the power of, you're going to increase the power, so to the power of 3, and then you divide by the new power over 3 minus, and you've got -3. This is going to be x squared over 2. So this is the integral of the function. Now what I'm going to do is find the area A by taking this value of the integral, or the expression of the integral, and evaluate it from 0 all the way to 3. Okay? So how do we do this? We say we're going to take the 3, we're going to substitute it into the x's, and then minus, we're going to take the 0 and substitute it into the x's. So I substituted the upper limit here, minus, and then substituted the lower limit here. At the end, you're going to get these two numbers subtracted from each other, which gives us minus 9 over 2, which is negative as we expected because A is an area under the x-axis. We do exactly the same thing for B. I take the answer of the integral and then evaluate it from 3 all the way to 5. So this is the answer of the integral, and I'm evaluating it from 3 to 5. So the first thing I am going to evaluate at 5 minus, then I'm going to evaluate at 3. So that's what I did. I substituted with a 5 here, and then I substituted with the 3, and I subtracted them. At the end, you get the answer 26 over 3, which is a positive value, and B is above the x-axis, so yes, it has to be positive. Now to find the total area, I've got to add A and B, making sure that the area A, which is negative, has to be found as positive. That is, I have to find the absolute value. So the total area is equal to the absolute value of both of them. They are both negative, but here we've got one which is positive. So area A, we found it to be negative 9 over 2. So we're going to find the absolute value. The second one, 26 over 3. And after that, you find out that the sum is equal to 79 over 6. And that's it. This is the area of under the curve x multiplied by x